Okay, so as I said, we are going to take a look at the quadratic formula. The what, the when, the why, the how.
Are we skipping them?
Yep, we're skipping those pages. We'll come back to them, but we're going to skip them. Okay. So yesterday we talked about, and we've been doing a lot of factoring of quadratics, right? We've been using all of the skills. We've been looking at GCF. We've been looking at product sum. Sometimes we have to use decomposition. We might get a question that's just a difference of squares. Like everything that you learned in grade 10 is now fair game for you guys to use. And the reason that we did that is so that when we have an equation, so when we have the equals 0, that we can actually solve for x and we get solutions for that. However, sometimes we're going to get an equation. Let's just fix this up. Okay, let's say, here's my example. Let's say we had x squared plus 3x plus 5 equals 0. Nope. Let's do minus 5. That's what's in my notes. Okay, so first, when we first see this, we'd be like, okay, we've got a simple trinomial. We can do product sum, right? And so we kind of set it up. We're like, okay, my product is -5. My sum is +3. Okay, the only factors I have of -5 are like 5 and 1. And there's no combination of positive and negative that will ever get me to 3. Okay, so when you have something that is not factorable, okay, this is where the quadratic formula comes into play. Because if we take a look at this, like, so pull out your calculator and we're actually going to like look at the graph. Let's see what this thing looks like, just to confirm that it actually has a solution. Okay, because we might look at it and say, well, we can't factor it, therefore there's no solution. Okay, that's not the case. So if we go to our calculator, okay, and we put it in y equals, let me clear what we had, and we do x squared, okay, plus 3x minus 5, okay, and we graph that. Okay, there it is. I can see it. But if you like look closely, you'll notice that the roots or the zeros or the solutions, that they're not exact like what we've been doing for the last couple, like the last week, the last few lessons. All of our answers have either been like an exact fraction or an exact number, like the answer is 5 or the answer is like -1. Okay, if we look at this, okay, we could still find it graphically. Okay, well, not that way. Let's do, okay, let's find our 0. So if I'm looking at, what did I do? This one. There we go. Okay. So if I want to find the -1, let me just go over. Okay. So I'm at the left. I scooch over. I'm at the right. Okay. Here I have like -4.19. Okay, so it does exist, but it's some irrational number. Okay, so the way that it works is if you can't factor it, we're going to use this beautiful thing right here. This is our quadratic formula. Okay, and it actually, don't fight with me today. What is going on? Hey, seriously, I don't want a fat marker. There. Okay. So you'll notice, okay, so we still have all of our A's, our B's, and our C's. Okay. So what happens is our standard form, ax squared plus bx plus c equals 0. We're going to learn how to get from this form to this form, but just not today. All you need to know is that the A in standard form is your A in your formula. Okay, your B in your standard form is your B. It shows up twice. Okay, and the A shows up twice. Okay, and then your C is your C in your formula. Okay, so literally all we're doing is taking your equation like this, okay, and we're just going to substitute in and solve. Okay, that's it. That's the surprise of the quadratic formula. Now, we are going to, we're going to look at it a little bit more because there are parts of it that will help us, and we need to make sure that we do it, that we don't have any calculator errors. Okay, I had a student last year, she set everything up beautifully, everything was right, and then her answer was consistently wrong because she wasn't putting it into her calculator properly. So we're not having any of that. Okay, But so just so you know where we're going in today's lesson, this is where we're going, okay? So you can see that we've talked about this before. We've talked about like the nature of the roots, right? Sometimes there are no roots, sometimes there's one real root, and sometimes there's two real roots, okay? If a question asks you for the nature of the roots, okay, and it asks you algebraically, because of course you could just put it, you could just graph it, right? You could tell me the nature of the roots. There's two real roots, I can see them. Okay, if the question asks you to algebraically determine the nature of the roots, that's where the quadratic formula or part of it comes in. Okay, we have something called the discriminant. Okay, the discriminant is this part of the quadratic formula. It's the radicand. It's the part that's under that square root sign. Okay, 4 squared minus 4, or sorry, b squared minus 4ac. Okay, this portion here is called the discriminant. And that just tells us the nature of the roots. Okay? So what you need to know is if the discriminant is less than 0, so if it's a negative number, okay, can you take the square root of a negative number? No. Okay? At least not yet. Okay, no, you cannot. In high school, you cannot take the square root of a negative number. Okay, so that means that if it is negative, if you were to put in the values of A, B, and C into that and you were to get a negative number, you could just stop there and say there are no real roots. There's no solution. Okay? If, when you do the discriminant, if you put the numbers in, okay, and you get the answer 0, that means that there's one real root. Okay? And if it's greater than 0, if it's some positive number, then there's going to be two answers. There's going to be two real roots. Okay, so let's take a look at what that looks like. Okay, so use the discriminant to determine the nature of the roots for these quadratics. Okay, so don't forget, here's your form. Okay, so obviously, what's A? What's the value of A? 1. Yeah. Okay, invisible mass says there's a 1 in front of the x squared, so A is going to be 1. Okay, B is going to be, is it going to be positive or negative 5? What do you think? I take the sign with it. So B is actually going to be negative 5. Okay, so A is going to be 1, B is going to be negative 5, and then C is going to be positive 4. Okay, so we take the formula for the discriminant, which is B squared minus 4AC. Okay, substitute in. Don't forget to put brackets around your negative. Negative 5 squared minus 4 times 1. What? 1 times 4. Okay. 25 minus 16. Okay, that gives us 9. So 9 is greater than 0. Therefore, I can say that there are 2 real roots. I don't know what they are yet, but I don't need to. It's just asking how many roots there are. Okay, there are 2 real roots. All right, your turn. Okay, figure out what the values of A, B, and C are. Okay, substitute them into the formula for the discriminant. Okay, and then just determine if it's negative, no real roots. If it's equal to 0, 1 real root. If it's positive, 2 real roots. So see if you got what I got when you sub in.
How do you know that there's one real root?
Because that's what it's defined as. If the discriminant is equal to 0, there is 1 real root. Okay, that's your definition. Shh. Okay, guys. Okay, the third example, did you see it? Okay, this is my reminder that you have to see the equal 0. So you had to push the 9 over to the other side. Okay, so that way it became positive 9. So when you put it into your formula, you ended up with a negative number. Therefore, there are no real roots. There's no solution for that last one. Okay, so just remember, however they give it to you, sometimes they'll give it to you like in a standard form. Okay, and if it's not in standard form, you put it in standard form before you do any substituting, or like we did that with the factoring, right? We had to get it in standard form before we could factor it. So same thing here. Okay, so that's the discriminant. Okay, this is just by definition. This is what the discriminant tells us. This is how we use it. Okay? So now what we're going to do is we're going to do some practice with, okay, substituting into the quadratic formula. Okay, making sure that we understand, okay, how to use it. So again, so here's the thing. When you get a question, your first thing, if you can, you should factor it. So always check, okay? Just take a look and say, okay, my product is 23, my sum is 10. Are there any two numbers that I can multiply, get me 23, add to give me 10? Okay, 23 is a prime number, so in this case, no, this one is not factorable. So then I would go to my quadratic formula. Okay, I'm going to make a strong suggestion. While you're getting introduced to it and using it, please write it out every single time. Okay, before you substitute in, just so that you get used to which one is being squared, where are the negatives, how do we use it? Okay, you'll notice that, okay, so when we write it out, okay, let's try that again. X is equal to negative B. Okay, guys, the formula has a plus or minus built into the formula because when we took the square root, right, remember there's always two solutions to a square root. If I asked you for the square root of 16, I would expect for you to tell me plus or minus 4. Right? So when we take the square root in the quadratic formula, there's two solutions, plus or minus. Okay, so you have to write the plus or minus, and then I'll show you, then we're going to use the plus to get to the answer, and then we're going to use the minus to get to the second answer. Okay, so we have negative b plus or minus the square root of b squared minus 4ac, so that's our discriminant. And then the whole thing is divided by 2 times a. Okay, so let's sub in. So x is equal to negative 10. So I do want you to write it out this way when we're subbing in. Okay, after, okay, when we clean it up, then you can write positive 10. But when we're subbing in, I need to see if it's b is negative, I need to see that you recognize that there's a negative. Okay, plus or minus, okay, negative 10 squared minus 4a and then c. And this is all over 2 times 1. Okay, so this is your substitution step. So show me the substitution. Okay, now we can clean it up. Okay, so we have x is equal to 10. Okay, this is where, okay, this, for now, okay, just until we get a little bit more comfortable with it, okay, I just want you to show me the square root with what numbers under it. So 10 squared, okay, that's going to be 100 minus, I don't know, 4 times 23, sorry guys. Okay, so we have y. Give me a second, my math isn't mathing for me right now. 10 squared minus, minus 23. There we go. Okay, it is mathing. Whew. Okay. Okay, so this is what I want to see right now. Okay, guys, I don't want to see any decimals. Okay, I don't want to see any decimals. Not until, okay. Depending on the context of the question, I would rather see an exact answer. So when we talk about exact answers, we're talking about radicals. Okay, I want to see the square root sign. I want to see it simplified. So we're going to do a little bit, we might have to do a little bit of review of simplifying our radicals. Okay, because how do we simplify root 8? You guys remember? Hopefully you remember it. Sorry, I think the heat is on in here. I am getting really warm. Just don't fall asleep or I'll have to open up the windows. Okay, I have to open a window a little bit. If you get cold, Carson, you can go ahead and close it. But I just need a little bit of a breeze. Okay. Okay, so guys, let's go through this. Let's remember, okay, root 8. Okay, when we simplify this, I'm just going to do it a little here at the side and then I'm going to erase it. So don't forget, when we do root 8, we look for factors and one of those factors has to be a perfect square. So we could say that this is the same as 4 times 2. The square root of 4 is 2, and then we're left with the root 2. Okay, so root 8 is the same as 2 root 2. Okay, I don't need to see this work. Okay, so you guys can go right to, okay, x is equal to 10 plus or minus 2 root 2 all over 2. Okay, so there, that was your whole review of radicals. Okay, can we still simplify this? Yeah. Do we need to simplify this? Yeah. Okay, it will never say simplify, you just do it. Like that's an automatic thing. Like when you see a fraction, if you see like 3 over 6, you just know that you put it in lowest terms. Okay, same with this. We're still going to put it in lowest terms. Okay, I'm going to give you 2 ways that you can show me. Okay, you can either do like a GCF, pull a 2 out of the front and go 5 plus or minus root 2 and show me that it cancels with the 2 on the bottom. You could do it that way. Okay, or you could like somehow be like, okay, like I'm going to just divide everything by 2. Okay, I guess you could do that part in your head, right? But at some point you need to, I just don't want you to miss anything. So like when you simplify, you have to simplify everything. If this didn't have a 2, you wouldn't have been able to simplify it. Okay, and we'll do some more questions where, like that's why I want to make sure our algebra and our math is solid. So for me, I actually like pulling out a greatest common factor, right, and factoring that out so you don't miss anything. Okay, so here our answer, I'm just going to write it up here. We have our answer is 5 plus or minus root 2. So that means that x is either 5 plus root 2 or x is equal to 5 minus root 2. Okay, this is an acceptable answer. If you were graphing this though, this answer is not very helpful. Okay, so if you have to graph it, then you would do like an approximate, and then you would like give me the decimal form if you needed to graph it. But if you're not graphing it, guys, I want this. Okay, I'm okay if you give it to me plus or minus, or if you pull them out. Okay, and show me 2 solutions. Okay, so you can stack them, or you can give me 2, but you need to recognize there are 2 solutions here. Okay, so the steps that we did. Okay, I'm just going to write the steps here on the side. So the first thing that you're going to do, okay, is you're going to substitute. Well, you're going to write out your formula, then you're going to substitute. Okay, you're going to do your discriminant first. Okay, then you are going to simplify the details. Okay, then you're going to simplify your radical. Okay, and then finally you're going to just simplify the fraction. Okay, and maybe like that was obvious to you guys, but just to kind of break it down. So first you write out your formula, you substitute. Okay, you do the discriminant first, you clean up the details, and then you reduce, okay, and simplify your fraction. Okay, so let's do one more together, and then I'm going to get you guys up at the board, just kind of practicing it out. Okay, if you're feeling good, like go ahead and like be working ahead. Okay, so in this one, okay, we have x is equal to negative b plus or minus b squared minus 4ac. Okay, square root of that all over 2a. X is equal to negative 28. Negative 28 squared minus 4 times 4 times 46. All over. Oh, yeah. Okay. So here's the thing. Should I have taken a GCF out? Yeah, my numbers would be smaller. Do I have to take a GCF out? If I'm doing the quadratic formula, the GCF will like come out when I'm simplifying my fraction. Okay. So both ways work. Okay. We're going to do like everything on this one. Okay. That's why we have a calculator here. Okay, so we have x is equal to 28 plus or minus. Okay, when I did all that, okay, I got 48. Okay, all over 8. Okay, and then I'm going to simplify. Okay, 48 is the same as 16 times 3. Right, square root of 16 is 4, so 4 root 3. Okay, and then I'm going to simplify this. I can divide everything by 4. Right. Okay, so that's how I simplify. Okay, so I pulled a GCF of 4 out, and then I did 4 divided by 8, which gives me the 1/2. Okay, so all of this is over 2. Now let's practice. I'm going to give you a moment to write that down. And then we're going to practice with our calculator. Calculators have gotten better over the years, so I think if you guys do this as a stacked fraction, you're fine. If you're like me and you maybe have an older sibling's calculator or even your parents' calculator, if you have like a TI-83 that doesn't do stacked fractions, then we just need to make sure, okay, if you have an older calculator, just make sure that you put brackets around the numerator before you hit divide. Okay, because if you were to just write this out, okay, without using the stacked fraction, if you were just to write 7 plus root 3 divided by 2, right, you're only dividing the root 3 by 2, not the 7 plus. Right? Your calculator is only as good as the user entering in the numbers. Okay, so for this one, just to make sure that we're using our calculator right, figure out what the 2 solutions are in decimal form. Okay, and round to the nearest hundredth. Okay, so I'm going to do it in stacked fraction form and also just in regular form. We're going to go 7 plus root 3 divided by 2. Okay, and then 7 minus root 3 bracket. Whoop, not there. Bracket divided by 2. Okay, did you get the same decimals? Okay. All right, so let's take a look at the next 2. Okay, I want you guys to, like, you can bring your notes with you if you want to look at it. I'll put it up on the board too. We're going to do the next 2 on the board. I'm going to get you to do it 2 ways because it is factorable. So I want you to do it factoring, and then I want you to do it again using the quadratic formula. Okay, and see how your answers compare. See how the 2 strategies compare, maybe which one you like better than the other. Okay, so head up to the boards, and we're going to be doing, okay, these 2 questions. 9x squared minus 12x equals -4. Okay, and the next ones. Okay, when we're taking a look at, so this one, okay, simple substitution. Okay, we can sub that in. We'll get 2 solutions. Okay, this one we could do decomposition or we could use quadratic formula. But I'm interested in this guy. Okay. So there's a couple strategies. I'm going to give you one. Okay. And then we'll take a look at another. So what you want to, so one thing that you can remember is that your goal, okay, is to get it in this form. If you want to use the quadratic formula, okay, if you want to solve it in a different way, that's a different thing. If you want to use the quadratic formula, you have to have it in standard form where it equals 0. So that means like we're going to have to expand this first. Okay, so you would actually have to do x plus 4, okay, minus 3 equals 0. Okay, once you have it in standard form, okay, now you can pop it into the quadratic formula. Okay, so if you want to use the quadratic formula, you would have to put it in standard form. So same thing here. Okay, you'd have your 2x squared plus 2x minus 3 equals 0. Okay. So you might be tempted, you might kind of look at this and say, well, that sort of looks like it's in factored form. Okay, factored form only works if it equals 0. If it doesn't equal 0, then you have to, right, remodify the quadratic so that it equals 0 and refactor it, right? Because these are actually not the factors. This is just something else. This is just in another form. Okay, so always make sure that you are putting it in the standard form before you attempt to either factor it, right? So now I can look at this and say, okay, I'm always gonna look to see if I can do, right, product sum. Are there two numbers that multiplied it as soon as I see 13, okay? And then I see 8, 13 is a prime number, so I only get to deal with 1 and 13. So unless my answer was like 12 or 14 for the sum, okay, this is not factorable, but I checked. Okay, and then you'd pop it into the quadratic formula. Okay, so I want you to finish, okay, those. We'll talk about the picture one, okay, we'll do that on Monday, okay. But you're all set to do the homework, okay. So there is going to be some homework, okay, in addition to your factoring sheet, okay. So you can go ahead and get started on the homework, but come and hand in your 10 a week that we did yesterday as an assignment that's due today. Okay, come and hand that one in.